How much copper can be obtained from 100 grams of copper sulphate? Oh my God. Now that's very, very easy and very interesting at the same time. You're asked, what is given? Given is 100 grams of copper sulphate. What is asked? Asked is mass of copper. I could use principle of atomic conservation. I can say that whatever is the mass of copper here, maximum that mass of copper can be obtained. But how do I get mass of copper in copper sulphate? Well, I have to resort to moles. I'll say 100 grams of copper sulphate and molar mass of CuSO4 if I wish to discover it. Okay, how much would be molar mass of CuSO4? Copper is 63.5 and sulphate would be 96. If I add this, this is 159.5. Okay, that's a fairly ugly number, very close to 160, but yet not there. So, moles of copper sulphate is mass by molar mass, which is 100 grams, divided by 159.5 grams per mole. Is that fine? Of course, yes. Which is 100. Yeah, 1 upon 1.595 moles. Now, 1 mole of copper sulphate molecules contain 1 mole of copper atoms. So, this is equal to moles of copper atoms. Yes. So, mass of copper atoms would be, therefore, mass of copper atoms is moles into 63.5 grams per mole, which is 63.5 upon 1.595. Oh my God, that is one ugly stuff. But this is a calculation I need to do. And if answer is the only thing that interests you, well, let me give you the answer. It is simply, nicely and happily 39.81 grams. The question ends here. But if you're curious, how did I calculate using hand? I can help you there. Again, it's not a part of chemistry, but these mathematical calculations are very simple. And my job here also is to give you a practice on how to do this. Let's do it together. If I have 63.5 divided by 1.595, how do actually I carry out this division? First of all, I realize 595 is like pushing to, if I just round it off, this is 63.5 by 1.6. Oh my God, is that the case? Yes, that is very much the case. Now, I also realize that 16 fours are 64. So, this is 64 minus 0.5. Why we are writing it like this? I just felt that, 16 can divide 64 perfectly. So, 16 fours are 64. This is 40 minus 0.5 upon 1.6. Now we are talking. Okay. Is this good enough? And then suddenly I realize that when I start reading table, 16 2s are 32, 16 3s are 48. Oh, 0.5 by 1.6 is approximately 0.48. No, it's accurately actually 0.48 plus 0.02 upon 16 3s are 48. So this is 0.3 plus 0.02 upon 1.6. Oh my God, this is negligible actually. If you just neglect this, it is simply 0.3. So this is 40 minus 0.3, which is 39.7. That's cutting it close. But then, could we not make it more accurate? Yes. One first approximation would be just roughly 40. If you're happy with 40, it's not a bad answer. But then you say, no, it's 39 point something. We have got this 39.7. No, I want this more accurate. I could have helped that also. Please calculate this. 0.02 by 1.6. How do I get that close? That is, this is 0.01 by 0.8, which is 0.1 by 8. Now 1 by 8 is 0.125. This is 0.0125. If you're so keen, you subtract that also from this. So 39.7 minus 0.0125. If you are so happy about this, let's round this off to 0.013. So this is 39.687. That should make you more than happy. It's very close to our accurate answer. That was 39.8 around. This is 39.7. We have cut it pretty close. That's the way you calculate by hand. One more thing. When you're calculating by hand, is the answer expected to match till 5th decimal space? No, not really. If you are within 1% of the exact answer, that's pretty accurate, and we are very much well within that range.